Welcome back to the lab. So, working away on Abby the Barina, with our ZX10R Kawasaki motorbike motor that's going into the back of it. Forgot to film an intro for this video actually, so this is all, I'm doing this Thursday night and we're going to put this video up in like 10 minutes, so I better crack on with it. Like, share, watch, enjoy, subscribe, stuff, things, watch video, comment and stuff. A little bit of distraction going on. Honestly, it wasn't much. I didn't put the gearbox in the transmission tunnel at all. I was doing other things. So, spuds, I guess we'll call them spuds. Locating dowels, probably a more technically correct term. They go right the way through. See that? Way through there. So that takes our massive, huge bolt holes that are like 21.5 ID on those bushes, OD on the bolts, 21, funny size anyway. Takes them from that down to 14, which is a realistic size bolt that you'd be able to get quite easily. So I've done all those, and the next thing is make sure it still actually fits. Sometimes that can go wrong. No drama at all. Just went straight in there. So, oh, it's sitting a little bit high on that one. It'll clamp down, obviously. So we'll go back to Nissan King. I forgot to get these fancy washers they have here. We'll get those. That's the subframe. Well, and some bolts. We need some bolts, right? Because I don't have any that particular size. And that'll be the subframe attached to the chassis. And then we can work on sorting out our differential and all that sort of carry on. We'll have all this. Might as well work on it on the bench for now until the last possible minute, and we'll get it back in the car. We've got a bit of a plan for what we're doing with the differential and a chain drive to the motor, which is going to be here somewhere. Obviously all this is upside down for anyone who hasn't figured that out. Our shock's on here, so we can actually, got to do those lower arm modifications that I want to do. Should still be able to run the sway bar. Might fit that up now so that I don't set things up and then go, oh, the chain's in the way, so we can't run the sway bar. So I'll crack on with that. It's looking good, getting there. Probably a couple of hours work and we could have that thing on its feet if we wanted to. Look at the mess in here. Anyone want some turbos? I've got one good one and one needs a new compressor wheel. Talk to me. Right, so we'll crack on with this. Getting to the exciting stuff now. Our first EV conversion. Electric motor there. I know it's electric because there's wires on it. Right, so EV. That'll keep politicians happy and some other people. Perhaps, maybe, maybe not. Anyway, so I was looking at mounting the old motor, sticking that on the frame, doing all that stuff like I say before we put that such mess, but I can't even hide the mess, before we put it in the back of that thing there. That way we can flip it upside down, do all the welding underneath and everything, and make sure it's all true and square and all that, do all the hard stuff just basically on the bench and get this as ready as we possibly can, and then smack it in the back of that thing there and deal with the rest of it. So somewhere over yonder, right in the middle of your screen, right there is a standard 350Z diff. It's a manual one. That's been used to give me some dimensions to figure out where our flanges end up in the diff cradle / subframe. They don't actually end up smack bang in the middle like you would expect. So that's cool. We've got a short shaft on the left and a long shaft on the right. That's all good. We're going to use I think it's a V35 Skyline open center for now. And there'll be some modifications done to that to seal up the center so we don't get rocks in there and jamming up his diff and screwing everything up. Those flanges will get butchered. They're a bit funny. It's like they just didn't want to do the machining on them and finish them off compared to the 350Z ones, which are all scalloped around the edges to save weight. These are really heavy. So they'll get modified for what we're doing here. Just using those because I've got them. and they're basically free recycling stuff. So basic position of the engine is about there, somewhere near enough. That's sitting just a little bit, the sump is a little bit lower than what the bottom of those chassis rails are. And the bottom of those chassis rails sit a little bit higher than what the floor is on the actual car there. So it'll keep the motor as low as practical, but keep the sump sort of somewhat clear of being bashed on things should he have an excursion from flat surfaces. So, and as you can see, we've got a sprocket on the motor there. Pretty much can't do anything about that. That has to go there. We can extend it this way, which would shift the motor towards the driver's side of the car, which is useless to us. We want to actually keep it as far to the left as we can to keep the weight and balance nice. Can space our sprocket that we're going to put on this flange here on the other side. Normally the crown wheel would go on that side, but we're going to stick this in the lathe, machine that side, put our sprocket on this side. Can space that out a little bit. Do still have to run some sort of bearing configuration to hold this thing here, so we have to leave enough room for that. So for now, just getting a ballpark idea of where things are going to sit, and it's about there. Now we're not too bad as far as the goal, just grabbing something to show you, of using the subframe without modifying it at all, trying to keep that as standard as possible. Here's a bit of chain going through there. We run a slightly bigger sprocket than that, and we can straight line through here without chopping into this. And same deal down the bottom there, heading towards the sprocket, clear of the subframe. We'll have to tweak this a little bit. I'm sure he'll be fine with that. It's just a guard to stop the chain jumping off, so we can just ping a little piece off the bottom here, and we'll be away. It's still going to be well clear of where our gear shift goes through there. And then I have to get on with making some framework to hold that in there and still enable us to get the electric motor in and out of the vehicle should it require servicing. It won't ever require servicing. Electric motors are so reliable. So that's, I mean, I say that sarcastically, but they actually are, but never mind. Nothing is ever easy. So, bowled into town, had a chat with the motorbike guys. So, apparently, it's on the bench behind me here, hang on. But they're a sprocket, though, which goes onto the, about there somewhere, onto that shaft. That makes it really big. It'll go really fast with that. That's 525 series chain that goes on this. This one is a little bit worn too by the looks of it, but not terrible. Hard to get that chain. So 520 series chain is easy to get, but not very strong. 530 series chain is the one that they use on the modern versions of the big bike motors and stuff. Nice and strong. You can't really get the what are we going to call it? It's not a pinion. The small sprocket that goes onto the motor there for the chain. Can't get that in 530 series in the size that we want. Nice and small to get a gear reduction that we want. So that caused a little bit of a problem, and went running around trying to figure out what size that we need for the back here, and basically everything that you could get off the shelf that we would then modify to work with this setup with the bike ratios. We'd still end up doing 270, 280 k's an hour with it, which is too much because this poor little thing, the clutch and everything's going to struggle to deal with that sort of thing. We want, in theory, top speed for the car, something like 170, 180 k's an hour. So to make this little thing scoot around on the autocross circuits as fast as practical, you know, as quick acceleration as we can get, because it's not going to be, we're not going to go on the salt flats with it and try and go a billion miles an hour. So, come up with a plan. I did come home, I've done some more maths, done some discussions. The whiteboard's been put to use, and you can see some numbers here. 15 small gear, 40 teeth on the big gear, times 2. And then that ratio that I'm writing here includes our 6th gear ratio, which is this. And then we're doing the maths that I showed you before with this magic number of when you work out your tyre size, revolutions per kilometre. So we can go through all these. This one here's got the magic pretty damn close to exactly what we want, and it's actually a combination. So here's what I'm coming up with. Motor. It's got a funny size number 1 cylinder on there, and they're all slightly oval, so it's not going to run very well, that motor, but never mind. So we got our little gear, we got chain, and we got the big gear onto a shaft with another little gear. Then we can get sensible drive ratio without crazy sized gears, because to get the numbers we wanted, basically, I had it was actually even higher than that, higher speed. I had it, actually, times that. I had 10 to 7 T. So I had 10 teeth here on the bike motor, and I had 70 teeth here. That's supposed to be 7 times the size of that. 70. And that worked out not too bad, because that times that, whatever that is. So it must be something, one of these. It was a reasonable speed. Except that puppy there ended up being 350 millimeters in diameter. And that, people, was not going to fit in that space there. It looks like it might do, but no way. No, it was way too big for that. So that's why I came up with that plan there. Spoke with the owner and I said, I want to do a double chain setup. Are you happy to do that? And we discussed, and I think he's pretty good with that. So ideally we want to have them both the same, so that we can have the same chain for both of them. So when we buy our 10 feet of industrial chain that we're going to use, rather than motorbike chain, we can have a section all cut, ready to go in his toolbox. And if one of these snaps off and disappears or wears out or whatever, you can just get the other one from the toolbox and click it on and carry on for the day. Why was my screen jumping when I did that? That's weird, eh? Oh, it's trying to focus. Right. So, there we go. The conclusion is one is going to be 17 to 45 and the other is going to be 18 to 45. I know, not the same. I just said they're going to be the same, but not, because that's how we get our 180 k's an hour. If they're both 18 to 45, it's 193 k's an hour, which is a little bit fast. Might make it work a little bit hard. And if they're both 17 to 45, it's 172 k's an hour. It's not really fast enough. If he's doing hill climbs and stuff, he'd probably hit that quite easily, I would think, depending on the grade of the hill. Certainly going to be faster than what it was with the old clunker that's in the front of it at the moment.